Okay everyone, this is going to be chapter 2.2 on thermal properties here. Looking at the first question straight away, a model thermometer consists of a flask and a colored water and a stopper with a glass tube passing through it as shown. So there's a glass tube, stopper, and then the flask. The model thermometer can be changed in one or two ways. The flask can be replaced with a larger one full of color. The glass tube can be replaced with one of a larger internal diameter. Which one of this is true? Now right here, if you look at this question, they say they have two changes, right? Number one, make the flask larger, or number two, make the internal diameter larger. Now if I use this, right, what's going to happen is, right, it will, using a larger flask is obviously going to increase the sensitivity, but using a larger internal diameter is actually going to increase the range. Which statement is correct? Using a larger flask increases the sensitivity. This is possible. Using a wider tube increases the sensitivity. Not possible. In fact, if anything, using a wider tube is going to decrease the sensitivity. Using a larger flask increases the sensitivity, and using a wider tube increases the sensitivity. Not true as well. Neither using, this is not true. So the only logical answer is going to be A, guys. If you use a larger flask, the sensitivity increases, and if you use a larger internal diameter, in other words, larger capillary tube, the range is actually going to increase. So A is definitely going to be the answer here. Which rule identifies the fixed points on the Celsius scale here? Lower fixed point and upper fixed points are always going to be 0 and 100 degrees Celsius. At 0 degrees Celsius is definitely the boiling point of pure water, and at 100 degrees Celsius, at 0 degrees Celsius is definitely the melting point of pure ice, right? And at 100 degrees Celsius is definitely the boiling point of pure water. So donkey is definitely going to be the answer here. Which property cannot be used to measure for measurement of temperature? Half-life radioisotope is definitely not going to be able to measure temperature. Length of a solid bar is through expansion through temperature, that we can use it to measure temperature as well. Pressure of a gas is going to increase according to temperature as well, and volume of a liquid is going to increase according to temperature as well. So the only answer here that cannot be used to measure temperature is going to be the half-life of an isotope. Then looking at this next question here, a glass tube passes through a stopper into a glass flask. Figure 4.1 shows that the flask is completely full of a liquid, and there is also some liquid in the tube. Okay, so there's some liquid in the tube and completely full liquid flask. The flask is immersed in a large beaker of very hot water. So you immerse it in a large beaker in very hot water. At first, the level of the liquid in the tube falls. This level of this liquid tube falls a little bit. After a short time, it rises upwards here. Okay, explain why at first the level of the liquid in the tube falls. Now today, if you remember about thermal expansion, when I lower this flask into hot water, what's going to happen is the heat is actually going to touch the glass first, right? And when the glass is heated up, what's going to happen is this glass is going to start to expand. When the glass expands, this volume of the flask increases, and thus the liquid level drops a little bit here. And this is what you're supposed to answer. As the heat expands the glass flask, volume in the flask increases, and thus the liquid level drops, right? Then after that, the next question, explain why the liquid level in the tube stops falling and starts rising. Once the heat actually penetrates through the glass and into the liquid, we understand that liquid always expands more than solid, right? So that is why after this, the liquid is going to expand and rise all the way towards the top. So if I were to write this down, it's going to be something like, as the heat reaches the liquid is expanded and rises towards the liquid expands more than solid when heated. Okay, as the liquid is heated, it expands and rises towards the top. Liquid expands more than solids here. Alright, then moving on to the next exercise here. Question number 1. A thermocouple is used to measure temperature. Which is an advantage of using a thermocouple instead of a liquid in glass thermometer? Now, thermocouples are known to have two main advantages. Number one, it definitely has rapid response to temperature, and it has a super large range in terms of temperature reading. So it can measure temperature range of -10 to 110. This is not true. It can actually measure anywhere from -200 degrees Celsius to 1100 degrees Celsius. It can measure temperature that change rapidly. This is logical. It is a linear scale. It is more sensitive. No, definitely not logical. All right, then moving on to the next question. A student wishes to calibrate a mercury in glass thermometer with a degree Celsius scale. Which value should she use for the lower fixed points and the upper fixed points? Lower fixed points and upper fixed points are always going to be 0 and 100 degrees Celsius. So lower fixed point is definitely going to be the melting point of ice, or the upper fixed point is going to be the boiling point of water, which is obviously going to be B in this case here. Two liquid in glass thermometers P and Q contain the same volume of mercury and have capillary tubes of the same length. Thermometer P has a capillary tube with a smaller diameter than Q. So P has a smaller diameter than Q here. Okay, having a smaller diameter indicates that it has a greater sensitivity. And this one here is definitely going to have a greater range lah. Because sensitivity and range, they are always opposite. You can only improve the sensitivity, you will forego the range. If you improve the range, you're going to forego the sensitivity. So look at here, greater sensitivity is obviously the one that is P, and greater range is obviously the one that is Q. So C is definitely going to be the answer here, guys. Right? Then question 4 here. The distance between two electrical pylons is 60 meters. An engineer fits a cable of 62 meters between the pylon. Why does the engineer choose a cable that is longer than the distance between the pylon here? Now, if you look at all the electrical poles, they'll always be dangling a little bit. This is because they are taking into account heat expand and cold contracts, guys. So on a hot day, it's going to expand more. On a colder day, it's going to contract and become a bit more tighter. To allow for contraction of cable in the cold weather, logical. To create a slope in the cable, nah, not logical. To keep the current low, not logical. To reduce the magnetic field, not logical. The only logical answer is A in this scenario here. A diagram shows a liquid in glass thermometer. Which changes increases the sensitivity of the thermometer? Sensitivity can only be increased by either using a narrower capillary tube or using a larger glass bulb, guys. A larger glass bulb here. So narrower capillary tube, wider capillary tube, thicker glass around the bulb is not going to affect it. The thickness of the glass is going to affect the responsiveness. Thinner glass is the same thing as well. So A is definitely the answer here, guys. Alright. A metal lid on a glass jar is difficult to unscrew. The jar is placed in warm oven until the jar and the lid reaches the same temperature. The lid is now easily unscrewed. Which property accounts for this? Thermal capacity of the jar, not logical, not logical. Thermal conduction, nothing to do with that. Thermal expansion is definitely the answer here, right? Because when the lid is relatively larger, it's easier to unscrew, right? And looking at this next question here, which factor affects the sensitivity of a thermometer? Yet again, sensitivity is either going to be the capillary tube or the larger bulb, right? So diameter of the capillary tube, number 1, definitely. The length of the capillary tube, no. The thickness of the bulb, no as well. So A is definitely going to be the answer here, guys. Alright. Then looking at this next question here, a thermometer used in this experiment has a small range and large sensitivity. State what is meant by the range. The range is basically the minimum temperature to the maximum temperature, right? So if I were to write this down, it would be something like the range is the difference between the minimum and maximum temperature. Okay, the range is the difference between the minimum and the maximum temperature here. Then after that, they ask about the sensitivity. Sensitivity is basically how much temperature, how much the liquid level changes according to the temperature change. Alright, so from here, sensitivity is the amount of change in the liquid, in the mercury, in the liquid thermometer according to the change in temperature. Okay, sensitivity is the amount of change in the liquid according to the change in the temperature. State and explain the effects on the range of the thermometer using a smaller bulb that contains less mercury. Now today, if you use a smaller bulb here, it actually decreases the sensitivity, right? Decreasing the sensitivity actually increases the range, guys. So you're supposed to state that, number one, the range is increased, and your explanation would be less expansion of the mercury per unit, less expansion of the mercury per unit temperature rise. Okay, range is definitely going to increase because there is less expansion of mercury per unit temperature rises. All right, then moving on to this next question here. In the space below, draw a labeled diagram of the structure of a thermocouple thermometer, including the devices from which a reading is taken. Now, our thermocouple will consist of a few key components, right? Number one is definitely going to be a galvanometer. For those who can't remember, a galvanometer is essentially like a millivoltmeter or a milliammeter. Today, if you want to change this as a milliammeter or also a millivoltmeter is acceptable as well. It will consist of one wire that is contacting the hot junction and also the cold junction, and it will consist of a different type of wire that is contacting both junctions as well. Once you have this, all you need to do is label each and every one of the part. This is a galvanometer. This is metal X. This is metal X as well. This will be metal Y. This is going to be your hot junction, and this is going to be your cold junction. Alright, so this is how you're supposed to do it. Galvanometer, hot junction, cold junction, metal X, and also metal Y here. Alright. Then moving on to this next question here. A thermocouple thermometer is used to measure temperature of a flame of a small candle. State two reasons why thermocouple thermometers is suitable for this application. Now this here is basically asking about the advantage of a thermocouple. You're supposed to mention that the thermocouples can measure rapid change in temperature. And also it can measure, thermocouples can measure large ranges of temperature. These are always the two key advantages of a thermocouple. Very standard question with a very standard answer as well. State and explain any effects on the sensitivity of a liquid in glass thermometer of reducing the diameter of the capillary tube. Yet again, the sensitivity is definitely going to increase. The sensitivity is increased. Why? Because more liquid is able to move up the tube. right? Whereas increasing the volume of the liquid bulb here is going to increase the sensitivity as well. Sensitivity increases, more liquid is able to expand. There is more liquid for expansion. More liquid is able to expand up the tube. Okay. And then finally, looking at the last exercise here. A thermocouple has graduations which starts from -10 and 110 degrees Celsius. What is the lower fixed point and the upper fixed point? Now in your IGCSE, sometimes they'll give you something like this. They're trying to bait you on the lower fixed point and upper fixed point here. Know for a fact that lower fixed point and upper fixed points are always going to be 0 and 100 degrees Celsius. Right? Which change in the design of the liquid thermometer makes it more sensitive? Yet again, either a smaller capillary tube or a larger bulb. In this case here, the larger liquid reservoir is the another way to say the larger bulb. Alright. Then the diagram shows a liquid in a glass thermometer where the temperature of the thermometer rises, the changes causes the liquid to move towards the right. Why does this happen when the temperature of the thermometer rises? Obviously the liquid is going to expand in this case here, right? It expands more than your solid here. Anything else is not logical, right? Then state the value of the fixed points of a thermometer. Yet again, it's supposed to be 0 degrees Celsius and also the 100 degrees Celsius. The graduation on a liquid in glass thermometers are equally spaced. For the equal spacing on graduation to be correct, state an assumption that is made about the liquid in the thermometer. Now, in order for us to have equal spacing in the thermometer, we are basically assuming that the liquid expands linearly or in temperature change. So we're assuming that liquid has linear expansion to temperature change. Okay, an assumption that is made on the structure on the thermometer. Basically, this one here, we're assuming that in order for us to have equal spacing in the thermometer, we have to assume that the capillary tube is equal in terms of its area, right? Its cross-sectional area throughout. You can't have a capillary tube that is opening up like this here, then obviously it's not going to have a linear expansion. So your answer here should be cross-sectional area of the capillary tube, double L I think, yeah, capillary tube is constant. Okay, then moving on, liquid in a glass thermometer A has a greater range than in B. State one way the thermometer A is different from B. If this one has a greater range, it means to say this one has a greater sensitivity and in order to have a greater sensitivity, the capillary tube here is going to be smaller, or the glass bulb is going to be bigger right? So you can write either one You can say like thermometer A has a larger capillary tube than B. Or you could even write that thermometer A has a smaller glass bulb than B. Then after that, liquid in glass thermometer C has a greater sensitivity. This is exactly the other way around, right? So state one way which the design of C is different from D. Thermometer C has a smaller capillary tube than monkey. And that's how you get your free 2 marks here. And then yet again, in the space provided, draw a labeled diagram of a thermocouple. It's essentially going to have a galvanometer, metal X here that is touching the hot junction and also the cold junction, along with metal Y here. So all you need to do is label all of this, right? Galvanometer, metal X, and also metal Y. Hot junction, and also your cold junction here. Okay. Then finally, suggest when a thermocouple thermometer is more suitable than a liquid in glass. Yet again, it's either rapid change in temperature or large temperature range. Rapid change in temperature or large temperature range. Okay, and that's how you're supposed to do these questions here.